Good morning. Thank you very much for basically being here or tuning into the video, whatever it is you're accessing the video from. And today I wanted to do a quick overview on the universe and the Milky Way galaxy. And this is going to be very short. So you guys already worked on the universe, you already worked on Jupiter, and we started out Earth and space science, basically doing an introduction of those concepts. What a planet is, everybody knows what a planet is. You live on one, Earth. You know what our solar system is, and you know what a solar system is. So it's a system based on a star, in our case the sun, and planets that are in its own gravitational region, so basically causing some sort of a unit around it. And then you know what a galaxy is, and then you also know what a universe is. These terms are well discussed and explained within this module here on Study Island. But I mean, some of the really cool things that I felt will be really interesting to talk about are basically, the galaxy and the Milky Way galaxy. So, galaxies are clusters of stars, dust or gas that are held together by gravity. This is a definition that's given here. And the Earth is a member of the Milky Way galaxy. The Milky Way galaxy is a fairly large spiral galaxy that contains hundreds of billions of stars. In some areas on Earth, in areas without excessive light pollution, the stars of the Milky Way create a band of light that can be seen in the night sky. The entire Milky Way galaxy is about 100,000 light years across. Now, this is a lot, but there's something beautiful about the way all of this has been broken down. What a light year is. A light year is actually not necessarily a measure of time specifically, it's a measure of distance. So these are some of the things that, I wanted to go ahead and touch on in this short presentation on the universe. Now, one really cool thing is the sun is one of about 100 billion stars spiraling about the center of the Milky Way galaxy, and it's located in a section of the galaxy called the Orion Spur, about 26 to 28,000 light years away from the galaxy's center. So the sun is about halfway between the center of the Milky Way galaxy and its outer edge. So that's actually pretty cool. So this is where the sun is hypothesized, or I would say thought to be in our galaxy. And our galaxy is just super huge. I don't think as human beings we'll ever be able to span across our galaxy other than just to see what lies in it or beyond it. I mean, if we were to traverse, I think the farthest telescopes right now, the Voyager 1 and Voyager 2, are more than likely still here crossing this heliosphere. This is basically the bigger outer boundaries that surround our own sun, and then moving into outer space. So, and it's been over 40 years since they've been sent, but you never know, maybe somebody might discover some huge wonderful warp technology and we'll be able to just boom, warp our way into the center of the universe, or maybe outside and see other things that are amazing there. And then the solar system is basically the sun and all the objects that travel around it, and they are trapped in the sun's gravitational pull. So I've mentioned this in class, and if you've been here, you've probably heard me say it. A lot of these our planets here in the solar system are pretty much, in a sense, exerting their gravitational pull on the sun, and the sun is basically kind of, in a quote, the boss in terms of its gravitational pull, because obviously it's the biggest of all of the bodies within the solar system. And the sun is at the center. And, one of the really interesting things is you have to be able to understand space in that light, that objects that are in space have a gravitational field of some sort. And depending on how they interact with other gravitational fields, you're going to be getting something of this nature. And then we moved on to talk about the sun and talk about the planets. And all of this stuff, is a lot of the concepts that you are already aware of by now, but I wanted to go ahead and highlight it because when we start to get, when we start to do some more high level stuff, like say maybe a quiz or a test, these are some of the things that you're going to want to be aware of when it comes down to it. And then another really interesting thing that we got to do over time was also some of the calculations when we looked at the different, and we did this in Edmentum. For those of you who did your the universe in Edmentum, you guys got to see how we did calculations for different models for the different planets. You got to see how we, we pretty much were able to come down with discovering a model by using mathematical calculations. Even here on Study Island, you guys were able to see how we use different calculations to be able to evaluate the masses of the different planets in comparison to one another. And so it's a lot of interesting concepts that we've been able to get our hands on when it comes to this. And then asteroids, comets, meteoroids, these are really, really interesting concepts. And again, one really cool thing that I wanted to basically, touch on before I end this clip is gravity and motion. So one of the beautiful things about our universe is because of the gravitational forces, there is motion that's also going on. And I believe strongly that these gravitational pulls are causing for the planets to move and rotate on their axes and revolve around the sun. So our rotations, they cause day and night in the Earth's own cycle. And I'm sure most likely on other planets you will get the same effect. The only difference is, the other planets are going to be rotating differently. In the case of the Earth, our rotation is 24 hours, and in the case of Jupiter, the rotation cycle is about 10 hours or so. So it's very, very fast. So if you're living on a planet like that, you're going to be it's going to be different if you could even live on a planet like that. I don't think there's any life form that we know that can withstand, the very huge variations in Jupiter's atmosphere and its own cycles. And then revolutions will also be a matter of, that gravitational pull and all those interactions. In the case of Earth, we revolve around the sun in 365 and a quarter days. That's basically kind of the calendar year. That's how we calculate it. And in the case of Jupiter, it's about 12 Earth years. So differences in size, differences in gravitational pull, these affect the movement of the Earth around the different planets. Anyways, the video has gone on for about 7 minutes. I don't want to bore you any longer. What I want to do though is I want to keep making some of these short presentations for you guys, but largely I want your questions because a lot of this you're going to be working through in a self-paced manner, and that's what I want you guys to enjoy more than anything else. So let me know. If you have any questions, you can use Clever to message me. It's the best way to actually reach out to me, and I'll be very happy to take and answer your questions. If you're in class with me, you can just, ask me a question. That's perfectly fine as well. So thank you very much. I'll end the video now. Have a good day.